Hello, and welcome to Autology, the podcast that brings you the latest on automotive technology. Today's episode is called Head in the Clouds Connected and Software Defined Vehicles. And you're here with me, Elisha Thakorlal, and Manuel Tagliavini, S&P Global Mobility Software Expert Analysis. Hello, and thank you for joining Autology today.
Hello, Elisha, and thanks for the audience for listening to this podcast.
Lovely to have you here with us. So, today's podcast is all about vehicle connectivity and its related software. But the first question that I really have is, a lot of people recognize, the cloud as a thing we upload our photos and other files to. But what role does the cloud play when it comes to automotive applications?
Well, I would say that cloud services that are traditionally associated with IT, web services, company collaborative software, and consumer application are increasingly becoming integral to the automotive industry. As vehicle becomes more and more connected, they rely on remote OEM servers for a variety of innovative services. These include intelligent voice assistants, real-time traffic information, and access to charging stations, all of which necessitate robust connectivity. Moreover, vehicles now require significant computing and data storage capabilities. By offloading intensive computational tasks to the cloud, there are tangible benefits, such as reduced vehicle weight, which in turn can enhance battery efficiency and extend the vehicle's range. However, this does not mean the elimination of onboard computing. Critical real-time applications with low processing intensity, such as certain control and safety system, still necessitate local in-vehicle computing to ensure immediate responsiveness and reliability. The storage needs for vehicles have escalated due to the proliferation of applications incorporating artificial intelligence or AI and machine learning. These technologies are not just limited to voice recognition, but extend to advanced driver assistance system, or what we call ADAS, and real-time navigation solutions, all of which require substantial data processing capabilities. The importance of the cloud ecosystem in modern vehicles extends beyond just additional functionalities. It plays a pivotal role in the software-centric nature of contemporary cars. Vehicles today are not merely electromechanical constructs, but sophisticated systems where software components play a critical role in functionality, safety, and user experience. The cloud is essential for delivering over-the-air or OTA updates, a feature that ensures vehicles are not only updated with the latest software, but also protected against cyber threats. These updates can enhance features, fix bugs, and bolster cybersecurity, all without the need for physical service center visits. Furthermore, cloud connectivity facilitates a new era of mobility solutions, such as autonomous driving and vehicle to everything or V2X communication, paving the way for smarter, safer, and more efficient transportation systems. It enables cars to communicate with each other and with infrastructure, improving traffic flow, reducing congestion, and enhancing road safety. The cloud is not just an adjunct technology for the automotive sector, but a fundamental pillar that supports the evolution of vehicle into connected, intelligent, and autonomous machines. The integration of cloud services into the automotive industry signifies a shift toward more software-defined vehicles, or SDV, where continuous improvement and innovation are possible through seamless updates and connectivity, thus ensuring that vehicles are not only meet the current demand of mobility, but also prepare for future enhancement.
Okay, understood. Amazing. Thanks for that explanation. And actually, I've also heard the phrase edge infrastructure being discussed in this space. Can you please outline what it is? Is it at all related to the Microsoft Edge internet browser? And also importantly, what is the difference between edge and cloud connectivity?
Well, thanks for the question. I would say, first of all, that is not really related to the Microsoft Edge browser. But I can tell you that when we delve into the area of edge computing, edge connectivity and storage, we are exploring a vital layer of technology that operates closer to the source of data generation that are our vehicle than distant cloud data center. This proximity is crucial for application where timing is everything. Consider like smart traffic lights and electric vehicle or EV charging stations that are integral components of vehicle to everything or V2X communication systems. These systems don't just communicate, they compute locally, making real-time decisions that affect everything from traffic flow to charging schedules. What we call edge infrastructure serves as a pivotal touch point in the broader network of connected automotive technologies. It's where real-time public wireless data meets local computation, enabling instantaneous responses to dynamic conditions. This capability is especially critical for a higher level of vehicle autonomy, like level 4 and level 5 autonomous vehicle, that, for instance, they don't just rely on the onboard sensor and system in the vehicle. They also draw on the swift computational power and data exchange offered by edge computing. This interaction allows for more refined path planning and control maneuvers, enhancing safety and efficiency on the road. Then we can add that with the advent of 5G technology, the potential of edge computing in the automotive sector is set to explode. 5G's ultra low latency and high bandwidth, they enable a level of interconnectivity and speed that can transform automotive use cases. Imagine vehicles that can communicate not just with each other, but with the very infrastructure of the roads they travel on, from traffic signal to road sensor, in all in real time. This technological synergy opens up new avenues for business opportunities within the automotive supply chain. As vehicles become more connected and autonomous, the demand for advanced edge computing solutions will rise, enabling new opportunities for innovators and suppliers. These developments aren't just about enhancing the current features of vehicle. They are about reimagining what vehicle can do, turning them into fully integrated nodes within a broader, more intelligent transportation network. Our research at S&P Global Mobility is focused on how this technological advancement will extend the software business landscape and influence the value chain dynamics within the self-driving vehicles, especially in the development life cycle. As vehicles evolve into more autonomous and connected entities, the software that powers them becomes increasingly complex and integral. This shift necessitates a revaluation of how we approach vehicle design, development, and deployment, highlighting the growing importance of software in an industry traditionally dominated by hardware. With the rise of edge computing and 5G, we will have a broader transformation in the automotive industry. It heralds a future where vehicles are more than just conveniences. They are active participants in a connected ecosystem, capable of interacting with their environment in real time, making smarter decisions, and paving the way for unprecedented levels of autonomy and connectivity.
Okay, brilliant. Thank you. And so, when it comes to actual applications, how are cloud and edge infrastructure used in a practical sense? And also, what is their role in helping create, the software-defined vehicle?
Okay, first of all, I would say that cloud and edge computing technologies are pivotal in the driving the advancement encapsulated in the CASE acronym. With CASE, we mean connected, autonomous, shared, and electric trends in the automotive industry. These innovations are reshaping the landscape of mobile network requirements and automotive computing, predicting a new era where vehicles are more than mere means of transport. They're becoming sophisticated, interconnected devices on wheels. As we went deeper into this era, original equipment manufacturers are laying the groundwork for this transformation by developing robust cloud and backend infrastructures. This strategic shift is essential for integrating future vehicles more seamlessly with cloud technologies, a hallmark of the transition towards software-defined vehicles. Such vehicles are not static. They evolve continuously through frequent over-the-air or OTA updates, integrating third-party services to enhance their functionality and user experience. The imperative of the case trends underscore the need for advanced connectivity solutions. These aren't just about staying connected. They are about ensuring that this connectivity is intelligent, high performance, and capable of supporting the complex data exchanges required by these next generation vehicles. For autonomous driving and e-mobility application in particular, the stakes are quite high. Quick, reliable, and low latency mobile networks become not just beneficial but essential, given their critical role in safety application and the need for efficient charging interconnection. When it comes to autonomy, especially at level above L2, what we call L2+, the approach to data processing undergoes a fundamental shift. The focus moved towards decentralization, minimizing latency, and enhancing data security by processing data closer to where it's generated. This is where edge computing becomes fundamental. By handling computational tasks closer to the vehicle, edge computing facilitates real-time decision making, a non-negotiable requirement for higher level of autonomous driving. Moreover, the integration of artificial intelligence into connected car capabilities like early diagnostics and automated vehicle inspections further illustrate the need for sophisticated edge computing platforms. These platforms are not just about crunching numbers, they are about enabling smarter, more proactive, and more efficient vehicle operation, leveraging AI to turn data into actionable insight. Cloud and edge computing are not just technological trends. They are the backbone of the transformative journey towards more connected, autonomous, shared, and electric vehicles. As we embrace these changes, the automotive industry is not just evolving, it's redefining what vehicles can do, creating a future where cars are integral active participants in the broader digital ecosystem, enhancing safety, efficiency, and the overall driving experience. But now, let's explore some compelling cloud-based use cases in the automotive industry, which include the connected car, autonomy, shared mobility, and electric vehicle, like I mentioned already before. Take, for instance, a level 3 autonomous vehicle. At the vehicle level, what happens? This involves intricate processes where signals from various sources like sensor, cameras, radar, and GPS are analyzed. This data is then processed locally to make immediate critical decisions. Shifting focus to the edge level, there's a fascinating interplay of data and decision. Here, information regarding the vehicle's path and decision is shared with the infrastructure. This collaboration ensures synchronized decision making among all connected vehicles, enhancing safety and efficiency on the road. Then, if we ascend to the cloud level, where broader, more complex processes occur, this is where fleet management takes a sophisticated turn, integrating data storage and computation for comprehensive asset tracking and remote motor monitoring, just to mention a couple of use cases. It's also the area where data collection for algorithm training happens, crucial for refining ADAS software. Additionally, the cloud servers serve also as a hub for gathering predictive maintenance data, which is pivotal today for preemptive services intervention. Now let's pivot to electric vehicle, particularly focusing on the electric charging infrastructure. In the vehicle, there's continuous monitoring of the battery, charge, and health, along with the calculation related to power consumption and estimated remaining mileage. This information is vital for the driver awareness and vehicle's operational efficiency. When an electric vehicle docks at a charging station, edge communication is triggered. This sort of setup facilitates the exchange of critical data, such as battery specification and charge status, and even details about the charging station occupancy. Finally, if we zoom out to the cloud perspective, where data on charging station occupancy is aggregated, this information is instrumental in optimizing route planning for connected vehicles, ensuring that they can find available charging station efficiently. Moreover, the gathered energy usage data becomes a valuable resource also for electricity suppliers. They leverage this data to fine-tune energy distribution across the grid, ensuring optimal usage and sustainability. These are just two examples highlighting how the integration of cloud and edge computing in the automotive sector is revolutionizing how vehicles operate and interact with their environment. The synergy is not just about enhancing vehicle functionality, it's about creating a more connected, efficient, and sustainable transportation ecosystem.
Okay, brilliant, understood. And I guess an important follow-up question would be, who are the key players in this evolving market?
Okay, here I would say that in this rapidly evolving automotive landscape, the advent of software defined vehicle and cloud technology is promoting a significant transformation. This change is not just technological, it's sort of reshaping, it's like reshaping the very fabric of the automotive OEM and their supply chains operate and innovate. OEMs are the heart of this transformation. They are moving beyond traditional manufacturing, venturing into new business models that are flexible, dynamic, and software centric. The integration of software development early in the vehicle design process marks a strategic shift. It allows OEMs to leverage to the power of design, simulation, and validation long before the physical vehicle comes off the assembly line. This approach not only accelerates development cycles but also enhances the quality and efficiency of the end product. Our extensive research at S&P Global, encompassing around 70 OEMs, reveals a spectrum of strategies being employed across the industry. Each OEM has its unique approach, balancing in-house and outsourced activities, which influences their journey towards adopting SDV and cloud technologies. We have analyzed various factors, including software development strategies, partnership, financial metrics such as ESG score and EBITDA margins, and software development resources to gauge OEM's readiness for this shift, resulting in what we call an SDV preparedness score. What's becoming increasingly evident is that OEMs are deepening their engagement in software development. This shift is not just about adding new features, it's about reimagining the vehicle's role and capabilities. Concurrently, Tier 2 suppliers and semiconductor manufacturers are broadening their horizon. They are not just hardware providers anymore. They are becoming integral players in the software domain, contributing to the operating system and broader software stack. This transition is leading to a more intricate supply chain, bringing with opportunities for innovation and collaboration. In this new ecosystem, startups are emerging as crucial innovators. With agility and a fresh perspective, these new entrants are focusing on consumer facing applications, driving product differentiation through software. They are set to grow rapidly, forging partnership with established industry players to bring new solutions and experiences to the market. Moreover, OEMs are pioneering a new business model centered on feature rollout. This model leverages subscription and on-demand services, allowing consumers to customize their vehicles post-purchase. This is not only enhance the user experience but also open up new revenue streams for OEM, transforming the car into a platform for continuous upgrade and personalization. In conclusion, I would say that the automotive industry is standing up at the cusp of a major paradigm shift driven by SDVs and cloud technology. This shift is redefining roles, creating new collaboration opportunities, and ushering in a new era of competition and innovation. For OEM and their partners, the road ahead is not just about adapting to change. It's about leading it, crafting as a future where vehicles are not just means of transport but dynamic, software driven companions in our daily lives. The journey is complex and challenging, but the rewards are a more connected, efficient, and personalized mobility experience for everyone.
Okay, perfect. And so, just before we wrap up today's episode, it would be interesting to know how valuable the creation of SDVs is for OEMs. I mean, would you say it will be their main revenue source following vehicle sales?
Well, here I would say that SDV enabled use cases will for sure become a relevant share of the OEM future revenue. Maybe not the most relevant one, but for sure the most probably the it's going to become the fastest growing stream of revenue, especially compared to the revenue coming from the sales of the car itself. New business model like subscription based one will become more and more common and adopted in the next future. This is for sure.
Okay, great. Thank you. But unfortunately, that's all we have time for today. A big thank you to Manuel for joining Autology.
Thank you, Alicia, and thanks the audience.
We'd love to hear your thoughts on today's episode at our autology at spglobal.com email, and you can find out much more at autotechinsight.ihsmarket.com. Don't forget to hit all the subscribe, follow, and like buttons to stay on track with the latest autology podcasts, and we look forward to you joining us again in the next episode. Bye for now.